Okay, good evening, everyone. Let me welcome you. Let me welcome you at Good Meetup number 8. We will be talking about the full stack of AI. I think we have great speakers and enjoy, guys. Before we start, let me quickly go through some housekeeping. So there will be 4 15 minutes presentations. There will be 15-minute break in the middle. After all presentation, there will be networking, refreshments, beer, pizza, maybe a KFC, we will see. And last but not least, if you need anything, just ask anyone having GoodData t-shirt. You can see the lady in the pink having GoodData t-shirt, so ask, for example, her. And let me welcome David Herel from BottleCap AI.
Thank you. Thank you for the introduction. I'm David Herel from BottleCap AI, where we are trying to make LLMs more efficient. So in my presentation, I want us to think about and think through how Europe can maybe lead the next AI wave. So if we go a few years back, or maybe even a few decades back, we can see that we can trace the origins of current LLMs from Fred Jelinek or even from Schmidhuber in Germany and Hochreiter from Germany, from LSTM, or we can have a gradient clipping, we can have a word-to-vec, or even mine contribution, the thinking tokens, which everyone is using. So as we can see, like a lot of the basics and fundamentals started in our continent. However, we've never capitalized on it. If you look at the market share of the technological companies, most of them are from US, not from EU. Like what technological company in EU we have with like decent capitalization, like ASML, maybe Spotify, and that's it, right? We don't have any like European Google. And I think even if you want to change it and you want to build cool startup, you want to build a cool product, you get successful, the biggest success or like achievement you could make here was to get acquired by some US company who will sell the product to us like in a few years later. And there are even examples of it, like Minecraft sold to Microsoft, and even our co-founder Beat Saber was sold to Meta, right? But for individual researcher or like engineer or whatever, I think it's even more difficult because let's say you make a cool research or you are good at coding, you go to the conferences, you open source the code, and you are really good, but to make a difference and to make a career, you basically have to go to US. There's like no way you make a career in Europe, right? So to be relevant, you need to go to US. But when I started doing the research in AI and was interested in artificial intelligence, I've never thought about any of this. I was just curious on how to build the artificial intelligence. And over the years, I've tried the many paths, like evolutionary algorithms, complex systems, cellular automatas, you name it. But ultimately, my PhD was about language models. Actually, the title was Novel Methods for Understanding Natural Language. And as I said, like if you want to make a career, I was trying to make something big. I was trying to open source the code. I was publishing, competing. We were like finalists at Amazon Alexa competition. And I think one of my like significant work, just to show the example how the big achievements can like start small or in Europe, was for example these thinking tokens, which everybody is using right now. Maybe you don't even realize it, but when you have your favorite LLM, you know you have this generating mode, or you have thinking mode where it thinks. So it originates to my research like 2 years back. I was like first one to publish it. So I'll just take you to the journey, how it happened. And to start off, I'll ask you the question, do you know how much is 56 times 37? Any guess? You don't, right? So I was asking the same question back then, Llama 2 70B, and it answered me it's 2092, which is wrong. And the answer is 2072. But you could argue that you don't know the answer too, right? Like you would need to do some intermediate calculations, you would need to write something probably, or do some more steps. And for LLM, it's not possible, right? Because how it works is you are trying to predict next word or next token. So basically, the LLM has to produce answer immediately. It can't think. So we were like thinking, what if we give LLM time to think? What if it can like produce more calculations with a hidden layer, and it can produce answer better? So what we did is that instead of letting LLM answer immediately, we put these thinking tokens which let the model think. Back then we were using these like just placeholder thinking tokens, and now there's like real text. So it's more interpretable, but this one also like had its advantages. And I did like many more stuff, which is like exciting, and I won't be talking about that because this is not scientific conference, right? But if you have a time after all the presentations, like I think there's like a lot of interesting stuff going on there. Like for example, this collapse of self-training language models and time awareness. Like there is no time in LLMs, no concept of a time, and etc. But since this is not scientific conference, right, I'll go back to some interesting story. Like I was doing internship at NUS in Singapore, and I had the opportunity to work at one of the best labs in Asia at Macaly, and I've met like one of the most brilliant students I've ever met. Were actually working there. They were like hardworking, sleeping there, like it was common on the desk. So I was like really surprised that when I was talking to them that their goal was to get a job at US company, right? Like they dreamed of getting internship or job at Google or DeepMind or Meta. And they seemed like really bearish on China, and nobody wanted to stay there. They wanted to go to US. Luckily there, I was there during the DeepSeek announcement, and I could witness how the sentiment changes like over the night. And now if I actually look at their LinkedIn's profile, they all work like for Alibaba, Tencent, like you name it, right? So, and when I meet them sometime, or like I chat with them, like they are bullish on China and they actually think they can make difference. So that was like wow moment. And but I was asking myself like, what about us? Like if I want to do something exciting or like work on LLMs, what can I do here? Like, is there like some good job where I can do it? Like, I don't think there's like many companies where you can do like exciting stuff, right? At least in Prague. So, like there are exceptions, right? But most of them are just like US companies. So, and I think partially it's due to the mindset. Like when I was in the US, like actually, if you finish the Stanford, it's like failure. Like in order to be considered that you are successful, you need to leave the Stanford and build startup. Even if you fail, like it's considered like much better than finishing. But can you imagine there if I tell you that I'm a math dropout, that you will think I'm successful? I don't think so. Like everybody thinks like you should finish the school, right? And if you drop out of Stanford, you are like failure because you didn't finish it. But so it was like completely different mindset. So I think that could be like one of the reasons. The other reason obviously could be like a lack of government support, but that's for another story. But yeah, so I think even if we are far behind in area of AI, I still think like we can succeed, that we can build the next wave of AI, or like cool products and big companies there. I think just we just need to don't be afraid and take a next step. And that's why we've created the BottleCap AI. Personally, I think you shouldn't be forced to go to US to make a difference or to make a big thing. And I also think that like when I was in US or Asia, everybody viewed us as a continent as just like factory for regulations or some like preserved history, you know. So we've named it BottleCap just like to reference it. So yeah, and I don't think I'm naive. Like I don't think we can outspend the US or China. Like there's it's not possible, right? But I think like we can out optimize them. I think there's like many inefficiencies, like for example, which DeepSeek showed, and there's like much more of this. For example, like one common myth, I think, is like this sentence that model needs to have 1B plus parameters to be able to reason. And many of these, which are simply not true, and a lot of people still believe in. So, but that's good because it benefits us, right? But yeah, so the whole idea was to give people a chance to actually do interesting work there. And that's the reason why we also created this no-cap test, where I think in this room, like we have tons of motivated people, right, who want to make a difference. So it's hard to do so because you need a lot of GPUs, and even if you have creative ideas and you think current LLMs are like inefficient or whatever, like it's hard to do it. So we've created the no-cap test where you can like easily try the ideas because it runs on a desktop GPU, and like if it's exciting, you can send it to us. So back to the start, like if I was asking myself, like nowadays, like if I want to find a good job or do exciting stuff, like 3 years ago, I would tell myself like I need to go to US to DeepMind or Meta. But now I think like the sentiment changes, and I think like one proof of it is that actually one submitter of no-cap test is leaving Matfis to join us. Yeah, that's it. Thank you.
Okay, now let me invite Christine to stage. Christine is from Qdrant, right? And she will tell us on building better retrieval. And I would like to mention one more thing. If you have any question, please leave them to networking. There will be plenty of time, plenty of beer, plenty of pizza, plenty of everything. So you can discuss with your favorite speaker or speakers, whatever you want.
Awesome. Okay, cool. Oh no. Tech. Oh, cool. Okay, I love that. Okay, nice. I don't use this. So hi, I'm Kirsten. I'm from Qdrant. Qdrant is who knows Qdrant actually? Okay, 1, 2, 3, okay, like 10 people. Okay, nice. That's good. That's not always the case. Let's go to the next. So just very quick glance into Qdrant, what it's doing. I have to do some marketing. Qdrant is a vector search engine. It's not a database, it's a search engine. It's written in Rust, so it's very, very quick. It's also, I like that we just had a topic with EU and open source. So it's EU made, it's made in Germany. It's open source, so you can just use it and then change it. And if you don't like it anymore, choose something else. And it has a really like very high dev first philosophy. So it's like really one of the main goals is to make it very easy to use, be integrated everywhere so that everybody can just start using it if they want to use it with some tool that they already have, like LLMs or like Llama Index, whatever. Next one, yes. still some marketing. So vector search is used in many, many cases. It's interesting right now because it's not just keyword search, it's more advanced, it's semantic search. So for example, on the left example, you see that there is an e-commerce store that sells stuff. And if you put in fruits and vegetables, it shows you all the fruits and vegetables, even though those carrots didn't have the description fruit or vegetable in it. So it works with the semantics. And then on the other hand side, what you see here is RAG. Has anybody heard of RAG already? Okay, lots of people, good. So what you usually use it for is, or like right now, is you use it for RAG backend where you want to give your model information that is very specific. For example, your documentation in a company. Give it to the model as like an API or something, and you can ask information that the model wouldn't know otherwise. Next. We can skip that. Cool. Who is very aware of vector search basics and is really bored if I talk about this? But it's nice. Okay, thank you. One person. But I'm gonna talk about it now because it was just one person. So the idea behind vector search is really you want to score in a search engine, like for example in Google, you want to score the documents up that are very relevant to the query of a user. Now the question is, how do I know something is relevant? You say if the question that somebody's asking in Google is very similar to the content of a document, then those are relevant because they're very similar, having similar content. And then next step would be, okay, how do we measure similarity? And this is by turning the content of a website, for example, into a vector because we know how to make calculations with vectors. Next. So there's, I'm soon done with the basics. So there's on the left side, you see sparse vectors. On the right side, you see the dense vectors. Sparse vectors, something that lots of people know, it's like a glossary. You can just turn a sentence into a glossary by counting the words in the sentence and then compare it to a query and see the overlap. And you see, for example, here, first query has a higher overlap with the query and the second one has a lower overlap. This doesn't store the semantics of a sentence. So on the right, you would have a dense embedding. That's, for example, with a neural network like BERT here. And what you can see, it's not just word count. It's like has floating numbers. There's way more information to be stored in those vectors. And so this way you can like capture interactions between tokens and store the semantics of a sentence. Now we are done with it, with the basics. So in my opinion, usually when you have a vector search or like any retrieval engine, there's always 3 steps involved. The first one is if you have Google search, you have billions and billions, I don't know what the high numbers are, of information that you want to filter down to show to a user. And so you usually have in the first step, you have a filtering process where you do like really coarse-grained filtering. Then the next step is you make on the like shortlist that you receive from the first step, you make you put a high precision model that is really expensive to use. So you use it only later before when you have a shortlist to not waste too much energy and money and so on and time. And then at the end you do contextual rescoring where you add information, for example, about the location of a user. If they search for a restaurant that is close to them, you can like tweak the scores based on like meta information. Next. Okay, so you can, of course, improve those 3 different steps. The retrieval you usually improve by having like a parallel connection of several encoder rankings, because this way you introduce diversity and you lose less relevant information by just like making a like wider and more coarse net. And this is because you don't want to lose the relevant information in the first step already. So later then in the precision step, in a precision rescoring, you just have a sequential scoring where each model becomes more and more precise and bigger and more expensive, but you do this in a sequential way so that you can keep the costs low. And the last step, the score boosting that I'm going to talk about today, yeah, it's the business logic. Let's go to the next slide. So what do we need score boosting for? As I said, you use it because everything else that you had before is just looking at the similarity between vectors. But yeah, you need actually more than just that. You need business logic. And yeah, examples for this is when you want to do geosearch, as I already had as an example. You want to have closer restaurants, higher ranked than further away restaurants. Or for time search, when you do news search, you want to have only more recent news and not the ones that are already 1 year old. Let's try the next, yeah. Quick deep dive also into what is inside those models or inside these functions and how you do it. First step is you get your first short list. You precisely rescore it or like use really high quality models to create a score. Then you apply the re-ranking formula and add the score on top of it in the end. So you have kind of like a hybrid between similarity scores and business logic. And this is in the end the actual scoring that you have for presenting to the user. Yes. The docs example, it's a little bit cut off on the side. It's okay though. What you can, for example, do is if you have the documentation of your company and you want to make it possible for your employees to search and find relevant documentation if they, I don't know, want to set up an API in your company's firewall or something, you would weight it higher if information is contained in the title of a document than if it's like lower down in the, I don't know, paragraphs, because the title is more descriptive of the entire document. So this is one way of incorporating that with just like a step function more or less. Then other example is on the next slide. GeoSearch, already talked about it. Close restaurants, get a higher score. And you put this all into a Gauss decay function, and by like providing the parameters that the function should have, for example, where should the highest point be of the curve? Should it be at 0 or maybe at some other place? And like the slope and everything. Yeah, by doing this, you can tweak those functions in the end. Next. 3 different decay functions. So what we have implemented is you can do linear decay, exponential decay, and Gaussian decay. Gauss you already saw. Exponential is looks different. It's more steep in the middle. We're gonna see in a second a video of that. No, we don't, because we don't have the video. And linear is used, for example, for pricing. That's okay. But here we have a photo or a screenshot. Yeah, I think you can see linear is linear, obviously. Exponential is really steep at the beginning. This is, for example, if it's for news. If it's like, if news is 1 day old, it's already irrelevant. And then, yeah, the smooth one for Gauss decay for, yeah, distances from a certain point, where it's like, okay, if it's like still 500 meters away from the user. Next. Yeah, this is how they change, depending on the parameters. Tips and caveats. Yeah, you use this if you know that your score really depends on like a numeric and you want to incorporate it into your relevance. You have to hard code it into your code. So before you apply stuff like that, you have to know in advance your data, the distribution, what meaning it has, obviously, and yeah, set it and be informed when you set it. And let's see what's next. Yeah, if you want to integrate it, or if you want to use Qdrant and you want to integrate it, as I already mentioned, there's lots of integrations. You can use it, as I said, also it's open source. You can use it in the cloud also. We have cloud, we have a free tier. You can just try it there. And let's see what's next. That's it.
Thank you very much for your presentation. And now we are right in the middle, so it's break time. I would like to thank David and Christine for their presentations. This was the first part of our meetup. It was, as you can see, really low level in the LLM stacks. And after the break, there will be let's say higher part of LLM stack, starting with Petr and Stepan following. So now stretch your legs, have a beer, have chlebíček if there is still any, and you can start networking. Thank you. Everyone, time is up. We will start the second part of our meetup, starting with Petr, who is the CEO of Macaly. Petr.
Hello there. Okay. So I've just a few questions at the beginning. So who here is a developer? Cool, a lot of people. Nice. How many of you sent any request to LLM provider with API? Okay, so cool. So in this talk, I will talk about how we built Macaly, which is a vibe coding tool for non-developers. We are focused on building websites. And at the beginning, just my experience, I work with LLM for the past 5 years when OpenAI announced GPT-3. Then I co-founded Langtail, which is still LLM ops startup, mainly for prompt management. But we were kind of bad at B2B sales, so we eventually pivoted to Macaly, which is much more understandable for normal people. And yeah, our target are like non-developers. So do you know different like competitor, for example, Lovable? Okay, few people. Okay. So yeah, this is Macaly. It's very similar to Lovable, but the difference is that we don't suck for building websites. What I mean by that, if you build a website, you usually needs to be good in being indexed by Google, Bing, now ChatGPT. If you build a website in Lovable, you are basically non-searchable because of their technical choice. Concretely, they use React and Vite. We are by default we are using Next.js, which is server-side rendering framework in Node.js. So this is Macaly, and what we can do right now is to try to create something, and I will go back to my talk, and at the end we will see if this like failed or if we got something like usable. So how many of you know a startup called Slido for questions? Okay, so we will try to one-shot it. So I will describe it here. Create a clone of Slido. So people can ask questions and I can pick an active question. The rest is going to be in the list. That should be enough, and we will see. So let's try it, and we can do one more fun thing. So we are in GoodData. So I created this kind of logo. It's a cyberpunk kind of GoodData logo. So we can create a cyberpunk landing page of GoodData. So visit gooddata.com. Is it .com? Yeah. And make a cyberpunk version of it. Use this cool logo in the hero section. Okay. let's try it. We will see. Now back to the slides. So now about how to build agents. How many of you try to build some agent? Okay, so I will talk about my experience. So I'm not saying that it's objectively correct or something like that. It's just how I see it. So there are basically 4 important layers where you can very much influence how it behaves, and that's instructions, tool calls, context engineering, and guardrails. So let's talk about it. So the first thing is that the LLM models are pretty much like Pokemon. So some of them are very good in UI, some of them are super fast and cheap, and you can use them for search. So for example, Gemini Flash 2.0, it's basically a search engine for us. Some of them are really good for debugging, but are slow. For example, GPT-5. And some of them are in the middle. So we are now using a Grok Code Fast, which is from XAI, which is super cheap, quite fast. Not very good for you, like UI aspect of things. I personally think that benchmarks are mostly bullshit. Like it's the similar thing when you are in a university, you could pass the exam, but you are not expert in that field. So we can see from some leaderboards that I don't know, that somewhere like Gemini Flash 2.5 is like stronger for coding than some like for example than Anthropic Sonnet, which is like maybe from the benchmark point of view it's true, but in a real world experience it's not true at all. So basically, I think what you need to do, you really need to spend time with the model. So yeah, you really need to use it, feel it, and all of models have different like biases, which I think you should maybe embrace them, not go against them. So for example, Anthropic Sonnet has this like you are absolutely right. It's using it almost every time when you say that something is bad. Or I spot the issue now even before it called any tool call at all. It said I spot the issue now, which is like it cannot spot the issue, right? Because no tool calls yet. So yeah, different models, different biases. So I think real experience and maybe your own internal benchmarks are much more interesting than trusting synthetic ones. Then in terms of instructions, what we learned that like what's typical is that you have some sort of instructions, and you spot some edge case, and you will add this edge case to the instructions, and this slowly makes the whole instructions very long. So for example, one of our prompt had 20,000 tokens with all the edge cases. So we thought that now it's going to perform a bit better, right? But that wasn't the case. It was slower, more expensive. So what I see is that you should try to do as small as possible in terms of token budget. So I think the sweet spot is around 3,000 tokens, and that's quite a small number of tokens. So what you can do about it is that you could, and we are doing that we basically have index of guides, like how to do something. And these guides can be loaded dynamically. So one of the guides is, for example, how to implement OTP signup. So the model can use a tool call to load the guide, and it has the step-by-step guide how to do it, and it works much better, and we can save some tokens. And I think like most of the people right now, I at least hope, using meta prompting, not like handwriting prompts. So it's usually much better to use like strong models such as Gemini Pro 2.5 to write the prompts for you. You just like describe it. Like I want like these guardrails, it should behave like this. So our instructions right now are basically only about Macaly is AI web builder meant for non-developers. Don't use technical jargon. These are the instructions you can load, and then that's about it. Models don't follow instructions well. It's very much depending on the model, but again, Sonnet, Anthropic Sonnet 4.0, for example, sometimes it's not using our instructions. The one example is that in our instructions, we have only use Next.js and Convex as a database. But when user is begging a lot, it can do Python for you. So, and it will say, when you debug it, why you did it. The model say, I'm sorry, you are absolutely right. I shouldn't do it. I will do better next time, but it will not do better. It's stateless, right? So, okay, so in terms of tool calls, our experience is that it should be as simple as possible, not like deeply structured objects like, I don't know, array of objects of, I don't know. Yeah, even array of objects is kind of bad. The thing is that these models can do mistakes, like even Sonnet is doing mistakes that it returns string instead of the real object for you. We are using super long descriptions for tool calls, so they have even, like, I would say more tokens than the main instructions. So we don't have description like this is a tool for editing files and that's all. We have like quite large descriptions where it's talking about all the good cases, bad cases. It's all injected to the main instructions anyway. And then we have a concept of core tools and secondary tools, which means that you don't want to have like 30 tool calls because that would mean that your agent suddenly has, I don't know, again, 20,000 tokens with each request, even like user write like thanks, but it will cost you a lot. It will be slower. So what we are doing is that we have some core tool calls like read files, edit files, and then we have secondary tool calls which could be activated by the core tool. So these like secondary tool calls are generate an AI image or search the internet. So you can also save some tokens and it's eventually even faster. But if you do it, you will burst the cache, which is then more expensive, at least for the first request. The more requests then are again cached. Yeah, in terms of context engineering, that's basically the instructions and then the messages. And you are trying, like, what's your goal is to use as small, like minimize the number of messages and instructions to make it, but have these tokens which are like very relevant for the given task. Which, for example, means that if you have 10 messages, you will not load most of the time 10 messages to the conversation, because that would mean that you are spending a lot of tokens. What you usually do is that, or what we are doing is that we are almost memoryless, but we are like fetching memory with each user request. We are trying to find what's relevant from the conversation to have the lean context. So yeah, we are using Gemini Flash for this. So basically with each request, Gemini Flash has goal to find like relevant memories from our conversation. And similarly, we are repeating the instructions. So if you say set up a database, we are dynamically, getting reminders like, hey, this is how you should set up database. It's also in the instructions, but these models, don't listen. So we need to repeat it again. Yeah, and we are doing that because obviously these like buffer of context is kind of expensive, and if you would not solve it, eventually next message would be overflow your buffer basically. In terms of guardrails, they are basically everywhere, and it means like For example, if you have a read tool to read JavaScript files or any kind of files, it could sometimes read a JSON file, which is super long, or CSV files, which is super long. You don't want to return these like content of the file back to the LLM because it would immediately crash. And these kind of guardrails are everywhere. So yeah, for example, with Bash, if you do bat grep, you will get so many data. So you need to always, truncate it, think about it. What we are, for example, doing is that with every edit of TypeScript file, we are returning back also the information from the TypeScript checker. So the LLM will just have this hint that it either did something good or bad, and it can try to fix it. So this like TypeScript check is good because it's deterministic. And then you could do like self review, which is basically meaning different LLM can try to check your code and say if the main agent is doing a good job following the instructions or not. So yeah, this is basically the Macaly architecture, which I already described. So we have some user requests like create a Slido clone, then some prepare phase where we get the sentiment from the user. So for example, if you say it still doesn't work, we will use this information and we will upgrade the model for you. So most of the time with this, we will use GPT-5 because there is a higher chance that it will fix it for you. If you say it needs to be fast, we will use faster model. We also detect the complexity, and we got the right memory, right instructions, and we basically all like hand off it to agent loop. This agent loop is where we basically wish that it will be good at the end. We cannot really influence it that much. And when it's done, it runs 25 like requests at maximum, then it will stop. And then we basically can evaluate if it's did a good job or not. But that's just for the statistical data. In terms of testing and evals, yeah, I need to be faster. Yeah, okay. So yeah, so what I want to say that we are not using evals that much. We are mostly using evals to test the instructions. If the model is, responding correctly to what we have in the instructions, like we wrote use Next.js. In our test, we try to send a request, use PHP, and it must like reject it, right? This is important mainly when you upgrade a model or try to use some cheaper model to still see if it's working correctly. And then A/B testing is, in my opinion, much better approach. It basically means that different users in our platform could get different version of agent, and then you need to have good statistical data like sentiment. For example, you want to have as small negative sentiment as possible for each message. Then this frustration thing with all the vibe coding tools, and it's almost impossible to fix it, is that when the agent is in a dead spiral, it cannot fix something for you. The user will pay it because that's how it works. So that's kinda bad because it's very frustrating that you spent your 1 hour of your time. You also spent $25 for that, but it's still not working. And that's basically what we can see on Reddit every day on these subreddits like Lovable, V0, Replit. Every user is like, it's a pool of hate there. And the bad thing is that I don't know how to solve it. It's quite unsolvable, I would say, right now. So the reality check, some people are saying that it's a fancy autocomplete. I'm not completely against this opinion. And yeah, AGI timeline, I don't really believe the AGI in 2 years is possible. And also in the terms of the training cost, each model right now seems to be just better than the previous one, but like marginally better, not like huge improvement. So what I would like to personally see is I want models such as Sonnet, but I like 5 times faster, 5 times cheaper, and that's what I think would make some things more usable, more enjoyable. And yeah, I also think that some kind of market, like AI winter will come. I'm not sure if it's like a few months or a year, but it will definitely come, I would say. So some key takeaways: you need to be friend with your model. You need to really know it. You need to keep lean all of your like instructions. Otherwise, it will be expensive and slow. Guardrails are super important. You need some observability platform to see the conversations, and A/B testing is how to improve the agent itself. So I don't want to end it with super pessimistic way. So I also want to say that my wife were able to create like important things for her. So for example, a budgeting app for her class. She is a teacher, and some few websites. So for non-developers, these tools feels magical. For developers, it's kind of so yeah. And this was obviously created in Macaly, and right now we can just very quickly check how we got with these two stuff. So one is Slido. Okay, we can create it. So create session, GoodData, data, okay. Did it create something or not? Okay. It's possible that it's not working. It set up the database, but yeah, okay. So let's skip this one. You can see it's web coding, and okay. Well, that went worse than I imagined. Okay, so let's end it like that. Sorry, it was a bit longer.
Thank you, Petře, for your demo and your presentation. I was a little bit afraid. I was like, oof, we are happy that you didn't create a copy of GoodData, but I think we are still safe, right?
Yeah.
Now we have last presentation. Our very own Stepan is going to present AI in analytics, a gimmick or a game changer. Let's see.
Can you hear me like that? Awesome, thank you. So don't worry, I will be quick because the pizza will actually go cold and I'm hungry too, you know. So I'm Stepan and I asked myself a question. Is AI actually a gimmick or does it change the game of analytics? And by that I mean, does it actually change how we use analytics? And as with all the great inventions, I went to history of LinkedIn, and the LinkedIn bros actually used their AI to connect to their databases, and then they put their legs up and they were like, now I can ask all the questions my database. I don't need my BI team anymore. And if you ask it, for example, what is my profit margin on product A? It could answer you something like 23.4%. But last time you checked, it was actually a little lower. So you're like, hey, wait a minute. Are you sure? So you ask it, I remember it being less last time. And it's like, oh yeah, good catch, man. It's actually 18.4. But now, if you have like a decision to make, and it's in hundreds of thousands of dollars or millions, do you actually choose the first one, which might be answer on top of some random tables? Or do you believe the second one, which might be a hallucination because you prompted it? For that, let's look into the AI-ready analytics architecture. Let's start with it by giving it a robust foundations. For starters, you really need some semantic layer because you need to base your queries on top of some, ground truths. You need to define those. You also need to provide context to the AI so it understands your whole company and your synonyms and stuff like that. You need to avoid hallucinations, so you don't let it do any computations. You just let it do something on top of your metadata, and then you crunch it yourself. God damn. Good. Then you need to do some workflows. So you need to slice your whole platform and create workflows that your users and/or AI can actually use. You have to orchestrate all the tools, give it to the users like the nails and the hammers and whatnot. But you also need to define guardrails, some sort of permissions. You need to make sure that if someone uses your platform, you can turn off certain parts, certain modules, so you can keep it safe. And last but not least, you need very good governance because you're working with AI. And imagine you leak your data to OpenAI. You don't want that, right? So you need to monitor what the agent is actually doing. You need to track its answers, and you need to be able to have a trace of what it did, why it shows what it did, and stuff like that. And last but not least, you need to have defined escalations. Now imagine AI is very creative sometimes, and even you can't comprehend what it can do sometimes. So imagine you have agent on top of your SDK or APIs, and it does what it is not supposed to do. You need to have some escalations in case something goes south. All right, now look into the AI and protocols, because I checked LinkedIn yesterday, and I saw two words repeating over and over, MCP and A2A. So look into those. First, as you can imagine, we have your platform or GoodData, and usually you would consume it through UI, APIs, or some SDK. But then some company comes and they're like, okay, you built all those tools and we want to use it through our agent. So you put MCP and they can connect to it. So you give it all the hammers, all the nails, and if they hit their thumb, it's their problem. So then you need to do the A2A, which actually connects your agent, which is all the knowledge you need to use all those tools, and you connected it to their agent. So they don't have to teach their agent how to use your platform, what are the limitations and whatnot. But remember, it's not about those two protocols. It's about being ready to have any protocol that might come, because in 2 months, there might be a different protocol and you need to have modular design. What I mean by that, you can see, it's better here. At the heart of the AI capabilities that are in GoodData, there are actually all the Gen AI services that expose all the capabilities that we have to the outer world. Through API, and we also do the monitoring, have LLM as judge, sometimes even as a jury. And as you can see, there's a barrier between GoodData AI and the analytics lake, and it's the semantic layer. And what it does is it creates a playground for the AI where it can play, experiment, and do its stuff, but we know it's safe. And as you can see, you have to be ready to connect any LLM provider. So if someone comes, and do you know those magic 8 balls, which you shake it and it gives you some answer. You need to be ready to cater to that LLM as well. And when I told you about exposing the capabilities of the platform, you actually need to have them in your platform. It's what creates what you can then use and cater to LLM. For example, like all the machine learning, you need to have it in your platform. The benchmarking, you can let LLM do any computations for you so far, and you need to be very fast, have caching, tiered storage, and also, as you can see, you need to have different entry points like APIs or even directly through Aeroflight, which makes it all possible. So how does our AI design philosophy work in practice? Let's simplify it and take our LinkedIn bros question. What are my margins by category? First, you enter LLM, which gives you the intent, which is to give a visualization. So now the LLM does a second step, and it actually extracts the keyword margin and category. Sorry. And then you can search these keywords in your semantic layer where you declared all your truths and you know the ground, how you want your analytics to be. So now you search and you can find, for example, profit margin and product category. Now you can construct the query on top of that. And we actually have our own language, which is read-only, so it's inherently safe. Then you can execute the query, which you need to translate to different SQL dialects, which is actually very hard. Have you tried asking AI to create anything in like long SQLs? It's very, very difficult. And then if you want, you can utilize LLM again. Once you have executed the query, once you have the data, you can provide it back and it can give you some suggestions or even summary so anyone can understand that. All right. What are the benefits of doing it this way instead of like raw dogging it, you know? So if you ask again the same question, maybe a little different, sorry. You can have AI on top of some tables, which can hallucinate. It can, it can cater to you. And instead of that, you can have your answer based on metadata. Now imagine there's no product margin in your semantic layer. The AI should be able to help you define this, and or you can provide it the definition to it, and it should be able to execute. So you can really like speed up the time between your thought of what you want to see in the data and you seeing it. So what does the future hold for AI-assisted analytics? There are 4 ways you can actually embed AI into your analytics right now. First one is assistance. It's actually the AI that's conversational, and it can help you onboard into your whole semantic layer, and it can help you understand what you are capable of doing in there. And once you know that, you can actually follow that up with copilots. And copilots actually are very interesting because once you are in the deep, you can actually see that, for example, it can see an outlier in your data and be like, that would be really nice if you had some drill down in there. Let's put it there. Why not? And then my favorite one is actually automations. Imagine it's 3 a.m. and there is some disaster and it reflects in your data. But you have automations in place. They are automatically scraped. There's some ML that actually does some anomaly detection, and it can use autonomous AI, which can then use the, for example, root cause analysis. So in the morning when you wake up, you are ready to make your decisions. We are walking on a thin ice when it's BI and it's starting to be decision intelligence instead, because it helps you create the decisions like that. And then, of course, agents. They're like the pinnacle of all those because they supersede every of them. But they are actually the hardest to have. Because, you know, creating agents that can create dashboards for you, that's very boring. If you want really good agents, you need to have open platform, you need to have SDKs, you need to have API first approach, so you can build anything on top of it. Like, for example, one of our UX architects, he likes to experiment with that. And he created a few articles. For example, he sketched the visualization and GoodData did it for him just because he could. Or some of your customers can actually, like, they want to use their mobile phone to consume the data. So you ask the agent, based on their SDK or APIs, please create an app that can consume it. So even if AI ceased to exist tomorrow, It already changed the game by bending the rules, or actually speeding them up. First is security, because everyone and their grandmother know that you shouldn't leak things to AI. Everyone wants to have their data secure. It always has to stay private, and there are huge implications across the platform. Second is simplicity, because instead of trusting your BI analysts, who you can fire if they don't help you, you now trust AI. So you need to be able to easily understand all the metrics and all the stuff, and it also needs to be easily extendable because AI needs to do that, and it's best if you can do it in small iterations. Then performance, because with that, you have so many people who will be using it, you need to cache everything. Like, for example, the root cause analysis I just mentioned a few minutes ago. Can you imagine 3,000 queries? Like, you would spend so much on Snowflake if you did that. You need to cache like 80 or 90% of all the queries, or you will run out of business. And lastly, accessibility. People use AI on all of their devices, so you need to cater to them anywhere. They use it on their mobile phones, on their smartwatch. You need to be ready for that. And don't forget to thank the devs of your platform who make this all possible. Do we have Lubko here? Goddamn. So shout out to him because his vision was really like ahead of its time, and he really made most of this possible. Thank you.
Thank you, Stepane, for your speech. Now, yes, I think. So Petr is going to show us results.
Okay, so the Slido, yeah, it was broken. Yeah. But right now I publish it. So if you go to slido-clone.macaly-app.com, you can actually join this GoodData session, and you can ask something there. It's real time, so we will see it. It's real time because of the convex. You need to use this code here to join the session. So you can try it. It's fun. And then in terms of the cyberpunk, yeah, do you see it? You can ask your designers what they think. There is data visualization in a cyberpunk way. And should be optimized for phones as well. You can try it. Yeah, wow. So yeah, that's how it was two prompts. Something was weird there. So is there any questions? Yeah, cool. How much is the fish? Okay. Thumbs up. Yeah, so that's all. Thanks a lot.
Nice. Thank you very much. Before we wrap this meetup up, I would like to invite all speakers to stage. Petra, you can stay here. Yeah. And Christine, David, and Stepan. Where is Stepan? Okay, we would like to give you gifts because we appreciate that you volunteered to be our speakers. By the way, this is Magda, one of our organization team members who was participating on this meetup. Except for others, except for Jessica and Tina. So I believe they deserve an applause. Thank you very much. Thank you, speakers. Now it's time for pizzas, beer, and party. Enjoy. I hope you like our meetup and see you at the top.